past, we have already discussed, we do have instructor-led live sessions, very similar to this, doubt clearing sessions. We do have our own projects. Eureka provides its own certification, and there are lots of assignments, quiz as well as projects, case studies, and hands-on. And you would have packed hours of live class sessions based on the batches you are selecting, maybe weekend batch or weekday batches. Based on that, this 30-hour session will be split up, either 3 hours a day or maybe 2 hours a day. On the page, you can go and then you can register yourself for some of the upcoming batches. The moment you register, a person from Eureka will be in touch with you to organize the batches for you. And you can just note down this coupon code. It's visible on the Eureka data page also, but just in case if you want to note down this, take it up webinar 20. If you use this coupon code, you get 20% off. Just if you face any issues in using this coupon code, you can always get in touch with Eureka support team. Just pausing here for 2 or 3 seconds so that you note it down. Okay. This is the part of the certification course program. Start with introduction to AWS. We do hands-on. And then we talk about security management in AWS. I'm not going to go through them in detail because that's not the session is meant for. This would show what are the topics we broadly cover on the Certified Solution Architect course. You can see that after every topic we do have hands-on. The hands-on, when we say there are 2 parts of the hands-on. One is the trainer does it on the live class. You don't have to specifically follow the trainer. You can listen to the trainer, see how the trainer is doing some of the hands-on exercises. And there are also some self-paced hands-on which you can do it yourself. On a common server, you are able to bring up the Linux OS as well as your Windows OS. You don't get access to these servers. And that's the power of hypervisor. Once you use this hypervisor, then you can bring your own virtual machines on top of them. So this can be your Windows virtual machine, and this can be your Linux virtual machine, and this can be, let's say, your Ubuntu virtual machine. And the applications which I have developed, which needs to be running on the Windows, I can put here. Let's mark it as W. Let's mark it as Linux, and then let's mark it as Ubuntu. So this is how we generally do. And when we say monolithic applications, so to be precise, to define you in a short way, that it's a legacy application. It's a very old application. It is not service-based, which means you have built the entire functionality of your application into a single piece of delivery, single piece of deliverable. And usually it is a very big system, and there is a single entry point and there is a single exit point for any of the monolithic system. So let's say I have application 1, and I have a start command, and I have a stop command. And I would just pack this, and then I would run on top of this Linux VM. This is how we generally do it. Now, on the contrary, when we say we split into services, so I have variable options now. I have option number 1. I can split my application. So what I do is I take my application, I split it into, let's say, UI services, and then let's say backend services. This is how we generally split the applications. And my UI can run, let's say that in backend I have 2 kinds of deliverables. I have some specific deliverables to, let's say, Windows nodes, and then I have some specific deliverables to Linux nodes. And my UI can run on any of the Linux servers. What I can do, I have 3 outputs to this. So I take a server, and then I again take a operating system. So let's say server, and then it has its own operating system. And what I do is I bring the container runtime. We call it as CR. It's called container runtime. One of the I take the Java runtime, pack my application on top of it. Very similarly, let's say I need .NET here, maybe .NET runtime I'll keep it here, and then I'll keep my specific application here. And all these applications are interconnected. They can talk to each other if just in case if they belong to a single application on top. And this part, if you want to talk about this separately, where I take a single box, I have my runtime, and I have my application package. This is nothing but your image. When we say image is very similar to the compact discs which we have used in the old days, where we shrink everything and then we try to put it on a digital versatile disk, DVD or a compact disk. And why do we do that? We can port it everywhere. So I can run it on my laptop. We used to have DVD drives. I can put it on my desktop and then maybe I can run it. I can give it to my friend and then he can run it. Irrespective of the configuration of the desktops we had, maybe it's the Linux desktop or it's a Windows desktop, a DVD and CD was always supported. Very similar to that, you pack this image, it's called as Docker image, because we use Docker to build this image, and this Docker image is shippable. Which means on this particular OS, let's say I'm using a HP Unix server, and then I'm running on an operating system called Ubuntu. Tomorrow I get a flavored application for, let's say, Red Hat Linux, RHEL, and then I'm going to use the same Unix servers. I feel that the performance on RHEL is better than Ubuntu. What I need to do is, I just need to take two things I need to do. One is install the Docker runtime, the container runtime on top of this OS. That's the first step. Once I install it, basically it's called installing Docker. You have seen that I have installed Docker. People say that. So I go and then I install the Docker, which means I'm actually installing the container runtime. Then after that, I'm going to take the image and then I'm going to just come here and run on top of it. That's all. Everything is taken care inside. So this is how containers basically work. We'll take a brief pass here. See whether there are any questions. Okay, Sakti, you're feeling that I'm promoting Edureka rather than the course. Okay, so this is a demo session, Sakti. We do that because it's assumed that most of you are new to Edureka. But when you get onboarded, I don't think so that you'll get contents on top of, about Edureka. It will be purely on the topic. Fine. So I don't see any other questions. Focus works. So you would feel that you will see that the similar content is present inside this PPT. I have explained in such a way that you basically understand the primary difference that we need to understand about containers is the use of hypervisors and the use of container runtime. This difference is what we need to see. We have the hypervisor here, and then we have the container runtime here. And on top of hypervisor, you can see that there is another layer added called VM, guest OS. Whereas when you use the container runtime, both of them are packed inside the container runtime. So which means that you can directly build your images, application images, then you can run on top of that. One layer of isolation is removed whenever you are using the container runtime. Okay, there is a question, small question. Let me pick it up quickly. It's a question from Valavi. In the virtual machine case, apps can't communicate. They can communicate. The communication between applications is primarily based on networks. It can be your private network. We call it a subnet. We call it as private subnet, or it can be via internet. It's possible on both the cases. Containers are mostly sitting on this in a closed network because it's a single host operating system. And even when you deploy multiple applications on a single host operating system, anyway, they are sitting in a closed network, the private networks, which means they will be able to communicate with each other. So we have talked about containers, and before we begin, is the way forward on AWS. Let me explain one more concept. So now we know that maybe we have understood that I had an application and I was backing this application. In terms of web application, we call it as web application archive. Let's just take an example. And what we usually do is we deploy a web server. Let's take one example as Tomcat or maybe Nginx. Nginx is another web server. So this is how we usually do. And this was the traditional way. And now what I have done is I have maybe refactored this application and I have created containers. Okay. So I have Docker H1 and then I have image 2. Fine. So what is the way forward? First thing, what we have done till now is I have refactored the application. I have split the application because it's a big, huge monolith application. It is very difficult to maintain. And I have split my application into two parts. The first part is packed as a part of image 1. Second part is packed as a part of image 2. So now I've used Docker as a tool, as a container runtime. I've used Docker to build these images, and which means that these images are readable by any Docker environment. If I have built in my laptop, these images can be unarchived, it can be unzipped, and then it can be read by any Docker. Most precisely, making sure that the versions are matching. It is readable by any other Docker environment. So what I do is, I take this container. I have built in my laptop, the developer laptop, and then I have the actual deploying environments here. Let's say we have a live environment. So here is where our AWS or maybe on-premises servers are running. So I go and then I just deploy these images. So what I do is I deploy image 1, then I deploy image 2. And just for basic understanding, let's say that image 2 talks to image 1, which means it's a running container. Let's say this is a UI application, this is a backend application. Let's take this as an example. And this UI application is exposed in some of the web server locations. So now when I run this, fine. So it's good. So I have one image and then I have two images. The very quick benefit that we are getting from here is, like, for example, if there is a change coming in the backend code, I don't have to bring down the complete UI application. What I can do is I can bring up another instance with an updated image. Let's say 2A or maybe 2B. It's an updated image where I have done some code fixes. I will bring up this image. And then what I'll do is maybe I'll also bring another copy of the same UI code. I will test this parallelly. Users are still using your first set, whatever we have here. This is what users are actually using right now. But in the backend, you have taken a copy of the UI. You have done some defect fixes on your backend code. You have taken a new image called 2B, and then your testing team or somebody is actually sitting and testing this. Once this is ready, what you can do is you can just switch the traffic from the outside users to this setup, and then you can bring down this. A very simple manual with manual intervention, obviously, but it is very easy to do. But on the other case, you can contradict saying even on the monolith application, I can make sure that I can bring up the entire monolithic application in a different stack. I can test it and then I can play with the traffic. Yes, it is possible. But the main difference is once you split these services, they become very small. And when they become very small, the restart time or the time taken to manage these small services become very easy, which means literally the downtime becomes very less. If you want to bring down your monolith application and you want to bring it up clean, it's going to take split the services. Yes, it's very easier for you, or especially that you can keep giving your updated releases and then you can bring all those services. And that's the power of containers, and that's the primary benefit of container. That your application is refactored to small and detailed services, then you can definitely go for a container-based deployment. Not necessarily that you always have to stick to containers. There can be a question on top of that. Why everybody is talking about containers? Maybe I will refactor my application, but I will still run them as non-container applications. Yes, it is possible. If your application is completely on Tomcat, you can run two different Tomcats, and then you can maybe split your application, and then you can run it. Nobody is going to disagree with you. As long as there is a necessity that if you feel that it is easier to manage, it is easier to ship, and then it is easier to provide multiple releases if you are using a containerized environment, then yes, you will get the best benefit of moving to containerized environments. First, okay, I've deployed the containers, fine. I need to have a registry because the development team is sitting and fixing a lot of bugs, and they are generating multiple images. So I need to store all these images into some registry. That is definitely required for storage and audit and all that purpose. So from the left side, people keep pushing the images, and from the right side, people pull these images and then they deploy to the respective environments. This is called as container registry. In Docker, it is called as Docker Hub. In AWS, it's called as ECR, Elastic Container Registry. That's where your images is getting stored. You can have your public, you can use public registry, or you can also set up your own private registry, even that is possible. Second part is done. First part I have deployed. Second part I have made sure that all my images are documented. What is the third part? Monitoring, which we talked about. When we say monitoring, so there are two aspects to it. One is that how is your stack performing? That anyway we will monitor. The second thing is your fault tolerance. This will make sure that an issue is going to occur. It is going to predict that there is an issue which is going to occur. So this will make sure that an issue has occurred, how the system can self-heal. We say self-heal, there is a fault. Fine, that's okay. Whenever there is a fault, the system will understand the fault and then it will rectify by itself, which means you don't need any manual intervention. We call it as auto-heal. Monitoring the performance, you can do it irrespective of containers or whatever technology you use it. You can always make sure that you can always monitor your performance. But when it comes to fault tolerance, even though it is possible for you to implement fault tolerance to some extent on your existing monolith applications, yes, it is possible. But when you take the fault tolerance concept to containers, it becomes very easy and becomes very useful. We do have a lot of concepts called auto-scaling, replica management. There are lots of concepts, blue-green deployment. We do have canary deployment. All these concepts are very specific to fault tolerance and high availability, which anyway we'll be talking in detail on the actual sessions. So I've just covered some of the basics of containers, and I have also covered how containers generally work when you compare with the traditional way of deployment. And what are the three main aspects of running a container? That you build a container, you store the container image in a registry, and then after that you deploy the container and monitor them. And when you monitor them, again on a subsidiary node, you take care of two things. How the application stack is performing, that you monitor out of the container, and then when some of the container crashes and there is a fault to your system, how the container system can understand the fault that they can rectify themselves. These are the aspects broadly that you need to understand when you are working with a container. The most used container platform is Docker, but it doesn't mean that you always have to use only Docker. We do have other container platforms like RKT. And Docker these days is mostly wrapped, which means Docker is provided as a service. You use Kubernetes, it is taken care by default. And when you use some tools like Rancher, again it is taken care by default. You don't have to go and then install Docker by yourself. You will have to. Very similar to that, when you come on to AWS, I presume that you know something about AWS, because in this session I cannot explain the basics of AWS. It's a web service. On that note, it has lots of services to replace all your on-premise workloads. Whatever you do on on-premises, you would be able to easily rent out from Amazon, and then you'll be able to use it. The primary concept is like, instead of owning the servers, you're for a short duration or maybe for a longer duration. Container is only one technology that we are using in the on-premise servers. We do use lots and lots of technologies. You might use Kafka. Is a messaging platform. You might use enterprise service bus. You may use a message queues, JMS message queues, or VMD on-premise. You migrate your peers. So AWS has to support. They will have to support all the tools and technologies which are using. Otherwise, obviously, you cannot parcel only 50% of your application to AWS and then the rest 50 you cannot keep it on your on-premise. Not going to work out. That is the reason if you pick any shining tools and platforms which is available on market, let's say Kafka, Docker, Kubernetes, Redis, Cache, if you pick any of the most widely used technologies, and when you go for a mapping with Amazon, Amazon will have an implementation by itself. It would have extended the implementation of those basic tools and then it would give an implementation on its own. What is the use of them? And this is how they can capture the market. When as an architect, when you go and talk to AWS, when you say that, boss, I'm using Elk, Elastic, Kibana, Elasticsearch. It's one of the most used BI platforms and big data platforms where we store lots of data on Elk. When you go to them and then when you say my data is residing on Elk and then without Elk I cannot migrate to AWS, then AWS will have to definitely work for migrating your Elk workload. They do have some AWS based Elk workloads. This is one such example. Very similar to that, if you say I am using Docker, in my on-premises I have installed Docker and then I'm running a lot of containers. Let's say I'm running 200 containers, 200 Docker containers. And when you go to AWS, AWS is going to say, I have an offering with me. You don't have to worry about anything. You can bring your code as it is, and then you can just ship all your containers as it is. Because even I will be giving you the Docker runtime, and it is understood that if your images are built using Docker, it can run even on my service. That's what AWS is going to say to us. And these are the three things which AWS will be offering us. The registry which we talked about. So I have my on-premise registry. So what I'm going to do is the moment if I want to migrate my workload from on-premise to AWS, I will be shipping all my images into the ECR registry. Once I ship, all my deliverables present on AWS. And once I do that, this is the first step. Second step is I need servers. So AWS definitely can provide a service. I will talk shortly about the EC2 and Fargate. I'll give some brief about them. I have my images. I have the servers. Fine, that's all. If I have the image and then if I have the server, I just have to go inside and run it. That's all. Even that AWS will do it for me based on the configuration. At the moment they are running, somebody needs to orchestrate. Somebody needs to make sure that the replica is taken care. The scheduling is taken care of. Some of the services I need to run only during the night time for maybe some batch jobs and all that. All those would be taken care of by some of the orchestration platforms called ECS and EKC. ECS Elastic Container Service. This is Elastic Kubernetes Service. So let's go to the UI and then see how we have two offerings. We'll talk about ECS and then we'll talk about EKS. As the name says, when you are using containers, AWS will make sure that it will prefer that you can go for ECS Elastic Container Service. That's again based on Docker. But if you are already using Kubernetes, then it would suggest that you can shift your with minimal changes to EKS, Elastic Kubernetes. So let's say that I have oops. I'll explain both of them. I'll try to give some basic understanding. I have used Docker and then I'm running containers. I have used Docker and I'm running containers, but I'm using Kubernetes to run these containers. Kubernetes is an orchestration platform. As the name says it right. Kubernetes is not going to give you any runtime and all that. No, nothing. What it does is like it basically starts and stops your containers. It leaves your containers. It makes sure that your containers are healthy. If it's not healthy, it will bring down. Then it will bring up a fresh container. This is what an orchestration tool does. And then container implemented. But over here on the left hand side use case, I am myself, which means that maybe I use some of the tools, or maybe my operation team is sitting and then they are watching all the 100 containers. I'm sitting and watching manually. If container number 50 goes down, I get an alert, and then I go and then I manually restart this particular 50 container. Both these options are possible. It is not necessary that you always have to go to Kubernetes. It's a very big topic whether you want to use Kubernetes. I think people have mixed reviews on top of that. You can always Google and then you can see what this suits you. But whatever you are right now on your on-premise servers, you can opt ECS here and then you can opt EKS here. Elastic Kubernetes Service and Elastic Container Service. Which means that if the input to use the ECS is nothing but your image, and the input to use EKS will be your image, and then we call it shortly as K8. K8 is called as Kubernetes. We need all your deployment files. We call it as deployment descriptors. These are YAML files where we basically define on Kubernetes. I'm not going to go in depth on that. We define the deployments and then we make sure that the deployments are happening. That's how Kubernetes works. You have the image, just an image. If you're already running your ecosystem, Kubernetes ecosystem, you just shift your ecosystem as it is to Elastic Kubernetes. And now, fine. So this is the software. The software is free of cost. Both these softwares are free of cost. What do we mean by software is the UI which you are seeing here. So this is a software where basically you go and then you configure your image and then you run your services. The software is free of cost, but the computes which you are generating, if you are running some server throughout the day, you get the per hour billing for the type of server which you are running. On both the sides, you have two offerings. One is based on servers. The other is called as Fargate. Based on servers, and the other is called Fargate. Server is pretty much understood. Anyway, we need servers to run the workloads. So when we say EC2 instances, we can define that this is the type of server I need. I need a 8 CPU machine, 16 GB, 128 GB or something like that. I can define my nodes and then I can make sure that I can run the images or the containers. Whereas if I don't know anything about the servers and my application is very small, I don't have to worry about the server configuration, installing the Docker and all that. I don't have to do that. Then I can go for a Fargate profile where ECS will try to understand the workload which my image or my container needs, and based on that, it is going to bring up. Definitely, it is going to bring up some server. But the only thing is, we don't have access to that server. AWS will manage the server for us. Primary difference is I manage the server, they don't manage the server. And the billing is same, which means that I have a clear understanding of what I'm getting billed over here. But here I don't have a clear understanding, but AWS makes sure that whenever your container is running, only that runtime is built for you. If your container is not running, if it is in an idle state, that will not be built for you. That's the benefit you get from the Fargate profile. When you're using Docker, the same concept applies when you're using Kubernetes. You're using Kubernetes, you can opt for your own servers. You say your own servers, it's not on-premise. It's on the AWS. AWS can spin up servers for us. Or you can go for server no, it's like maintenance-free server mode called Fargate. So let me take a small demo, and then after that I'll take your questions and then ECS and then do a small demo. This demo is something which anybody you can do it by yourself, and this is not the demo that we take it upon the actual sessions, because on the actual sessions, the demo what we are doing, it is going to take at least half an hour to 45 minutes. It's a complex demo, but for you to understand what exactly we are doing in a container service is this. There are 4 things which we need when you want to migrate your Docker containers to ECS. Definitely you need a container definition. It's nothing but your image name and version. You need a task definition. In ECS, we call a task as a running container. So what the task says, it's a simple task. It's a definition. What it says is like, you take this image and then you run it in 2 replicas. That's a task. And there can be another task which says you take, let's say version 1, you take version 2 image and then you run it in 2 replicas. This can be another task. This is what we define in ECS. And multiple group under service. This is your, you can call it as your application service, your backend service, UI service, audit service, and all your audit containers can run inside your audit service. It's a way of grouping your containers. And finally, this cluster is nothing but your application, entire application, which is running inside a single cluster. Let's do a small configuration and see how it works. Let's pick engines. Let's pick the sample. The only difference is we are going to keep engines Docker image. Instead of that, you'll be having your own Docker image and then you can configure that. To do that, you go for this custom configuration. Whatever you have here, you'll use this. So let's rename this. Let's give some specific name. Let's say it will pick a demo, something like that. Save this. This next. We have defined 2 things till now. The image name is already preloaded, and by default it creates a single task. You can go, once you create the cluster, you can go and then you can add multiple tasks. By default it creates a single task. We have just named the task as Eureka demo. Let's attach an application load balancer because we will be running multiple replicas, which means the moment you run multiple instances, we need application load balancers. Just create them. Let's give some name to the cluster. Let's say container cluster. Let's just review and then create. Let's observe what it is actually doing. So it creates the cluster. And once it creates the cluster, and under cluster, it will basically create 2 things. The cluster can have multiple services, and then the service can have multiple tasks. But for here, we have a single service and then a single task. Go and we can add. Creates a log group for monitoring. All your containers logs will be present here. You can use some services like CloudWatch to monitor specific log group. You can give your own Help instance of what you have. The cloud formation is an automated configuration management tool where if you want to delete your cluster and if you want to update your cluster, AWS makes sure that it uses the stack and then updates. It's your own network for your application, your private cloud, and your own public subnet and private subnet, it gets generated by default. And a security group, which again basically makes sure that only these ports are open from your services, other ports are not open by default. Let's say by default SSH port and HTTP port will be enabled, other ports like UDP will not be enabled. And finally it creates a load balancer. Takes some time and then it creates everything, and once it creates, what we can do is just go and then we can see how the task and the service is configured. Let's pick the one which we have created some time back. See that there is a single service, engine service under the cluster, and I have a single tasks. What I can do is like I can click create new task and then I can create a different container, not just the same container. I can bring in a different image and then I can run them. I can group the containers under a single service. If I have a service called billing, under billing I might have 10 services, 10 development teams. They will be giving me 10 different images. So I can group them everything and then I can possibly use them. So let's see what happened to our cluster. Container cluster is what we were creating. Still coming up, so let's give some time. So that's about it. In the meantime, this cluster is coming up, and let me show you the default engines page. Let me see whether there are any questions. Okay, there is a question from webinar registrant. I couldn't get your name. GCP has clusters, contains VMs. I'm new to AWS. What about clusters in AWS? A cluster is basically a logical separation of group of VMs. What you mentioned about GCP is fine. Irrespective of the cloud providers, whenever you say that you have a cluster, the moment you say it's a cluster, it's more than a single server, more than a single VM. And the moment it's a single VM, it's called a standalone. There are two concepts, standalone and cluster. And standalone is obviously the single server. Cluster is the moment you have more than one server and they are related to each other. When we say related to each other, the same application is running in multiple servers. That's called as a cluster. What is the difference between ECS and Fargate? Fargate is an offering under ECS, James. So ECS has two offerings. One is the plain nodes. You see here, you can come here and then you can add your nodes. You can register your instances. You can supply your own servers. You can supply your on-premise servers also, provided you have connectivity. And you can provide AWS services. So this is one way of doing it. Whatever we have done is AWS will generate the server. You don't have to supply any servers. Based on the Docker image, based on the load it needs, it will bring up applicable servers or corresponding servers, and then it will run it in the background, which means we don't have any access to these servers. It is just fire and forget. I have the image, that's all. My entire container runtime environment, container management is completely handled by AWS. And I'll be billed only when the resource usage goes up, and if AWS is bringing up more than what is required, only then I'll get billed. The billing is primarily based on the usage. Okay, I don't see any other questions. Okay. Fine. So we have covered the topic. I think, yeah, I know I can understand that 60 minutes is not sufficient for us to completely cover the containers. It's quite difficult. But I believe this will give you some idea, like how the more than the containers, especially for people who already know containers. I think this will be a kind of theory that you have already gone through or you have already worked upon. But definitely this will give you some idea, like how the training goes with the Dereka. And this is the way that most of the trainers, all of the trainers on Dereka, we teach people. Let me open the voice chat. What you need to do is there is a raise hand option. So you could see that option on your left side. And when you click that, I'll get a notification that you want to talk to me. To keep this session for maybe 5 more minutes, I'll wait for some raise hands. In the meantime, I'll cover some more content on the Edureka LMS. I've not seen any raise hands yet. I hope. Okay, I've seen one raise hand. Let me talk to him. It's from Lalit. Lalit, I have unmuted you. You should now unmute yourself and then talk to me. You need to unmute yourself.
Yeah. Srinivas, can you hear me?
Yeah, able to hear you. How are you?
Yeah, I'm good. Thank you. I want to see, I hope, my Nginx container is up right now, and can we see it in the browser? How are we going to access the URL?
Sure. So, since we have attached the load balancers, right? AWS would have brought up these load balancers for you. Just copy. By default, we have only load balancer DNS, but if you want a proper DNS, you should be using Route 53. You use Route 53, you can attach multiple load balancers, and this is a sample page, whatever we are seeing here, right? The Nginx, welcome to Nginx is what you get. This URL, whatever we see on top, the complex URL is nothing but your load balancer URL. So what has happened now is, let me explain. Bring a white board. I have an Nginx image, and what I do is I configure this image for my ECS cluster. What ECS does is it brings up a cluster, and for simplicity, I have a single EC2 instance running. This is running in Fargate, which means I won't be able to manage these EC2 instances. There is a single EC2 instance where AWS makes sure that it brings up this EC2 instance, it installs Docker, and once it installs Docker, it picks up my image and then it runs my image onto this EC2 instance. And once this is done, it creates a load balancer, application load balancer, and then it attaches this EC2 instance to this load balancer. By default, load balancer will have a DNS, public DNS, and this public DNS is visible to me. As a user, I can access this. So when you do this demo, this is what AWS does. But what we can do is, this is a very simple use case, right? I mean, if I want to run a single container, what is the point of doing these case? What I would generally do is, I will create a cluster, and inside the cluster, I will create two services. This is a typical example. Service 1, service 2. My service will have service 1. Let's say, let me give some proper names here. So let's say this is a billing service, and this is a CRM service, only the customer relationship management service. So this service, I have a couple of development teams. They have, let's say I have two deployables. One is retail billing. The other is commercial billing. Just some example. This has an image. This has a separate image. This goes into task 1 and this goes into task 2. And when I create these tasks, I will be using this image name here and I will be using this image name here. And what AWS will do is, it will create the cluster. It understands that you have given two tasks. Each task corresponds to different images. And when we give the tasks, you can do some configurations. We have not seen all the in-depth configurations. Right? You can say what is the minimum memory I need, what is the minimum CPU I need, and all those configurations I can tune. And when I tune that, based on the configurations, AWS will bring one EC2 instance and another EC2 instance, and then it will run this container over here, and then it will run this container over here. And it will possibly attach, if that is your configuration, it will possibly attach both of these containers into a common load balancer. And you can also do a route specific configuration where you can manage multiple load balancers for high availability. And then this is the endpoint URL which you will be giving to the user. This is the ideal configuration. And when this is running continuously, you can go and then you can dynamically update it. What you can do is, I need another instance of task 2 to be running. Maybe I'm getting huge volume from the customer billing or the commercial billing. I'm getting too much volumes. I need to run one more instance of this. Just go and then just update the desired amount of containers that you need to run. That's all. What it will do, it will bring up another EC2 instance if required, or it will run on the same as a Docker. If required, it will bring another resource and then it will run a copy of your container, and then it will automatically attach to your load balancer. All these can be done whenever you are using this. Same way, I think you can do multiple services, and all these services will be available on your single cluster. That's what we have done. I hope that answers.
Yes, it's very clear. Thank you.
Thank you, Lalit. I'll get you now. I don't see any other raise hand options. Okay. We have 2 minutes. Let me quickly go through the LMS. So, the moment you select any particular Radioloca course, I just wanted to cover this as a part of the webinar. You get an account like the LMS account, Learning Management System account. You get very similar to this, like what is your upcoming courses and what is your ongoing course, and then what are your completed courses. So if you pick any courses which has been allotted to you, you get into this sort of landing page. Let me quickly go through the course content. You have the AWS Solution Certificate Solution Architect. It has around